Hi everyone. Okay, so today we're talking about some more about thermal energy and then also about temperature. But before we get into thermal energy and temperature, we have to clarify a couple of definitions. So the first one is mass. Go ahead and write this down in your notes. Mass is the amount of matter in an object. So more matter equals more mass. And so often we can look at something and say that's really big compared to this other thing, so that has more mass. But we do have to keep in mind the number of molecules and the mass of those molecules. So we can approximate these things, but it's helpful to be able to actually measure them in order to determine what has more mass. All right. So this is an easy example here. Which one of these has more mass? Is it the little kitten cheetah or is it the full-grown cheetah? We can assume that these are both the same density, right? So they have the same number of molecules in each part of them. So because this cheetah is so much bigger than the kitten, the cheetah has more mass, and we can be pretty sure about that. All right, another vocabulary word, kinetic energy. This is the energy of movement, and we're going to talk about this a lot throughout this unit. So objects or molecules moving faster have more kinetic energy if they have the same mass, and we'll get into that a little bit more. But let's say I have these two pens. These are definitely the same mass because they're the same type of pen, even though they're different colors. So let's say I hold this pen here and I drop that pen. As the red pen was falling down, it had way more kinetic energy than this because this wasn't moving at all. All right, so let's go back to our puppy from yesterday. What do you think? Does this have a lot of kinetic energy or very little kinetic energy? So it's kind of a small puppy, so it doesn't have much mass, but it does have a lot of speed. So we'd say that has definitely some kinetic energy. And let's compare it to a puppy of roughly the same size or the same mass. Okay, so this is a puppy that's about the same size, maybe a little bit smaller than the other puppy. And this puppy's kind of sleepy, so it's not really moving at all. So which one of these two puppies, the one that's zipping around or the one that's snoozing, which one of these two puppies has more kinetic energy if they're the same mass? The answer here is definitely the faster puppy. All right. Now, which one is cuter? I don't know. That's a different question. We'll take a poll after. All right. A couple more vocab. So I know we already did thermal energy yesterday, but I also want you to write this down because this is getting more technical, and we're going to need to understand this a little more in depth in order to figure out some stuff about the experiments that are coming up. So thermal energy is, remember we said it's another word for heat energy. That's a general definition. More technically, it's the total kinetic energy of all the molecules in an object. That means that if we have bigger objects that have more molecules, they could have more thermal energy than smaller objects, depending on how fast the molecules in those objects are moving. Basically, depending on how hot they are. Okay, so that's a little tough to figure out just from a definition, so we're going to look at another example. Oh, there it is. Okay. Which one of these has more thermal energy? So these aren't really to scale because obviously this bathtub should be way, way bigger than this coffee cup. But check it out. This is a coffee cup that's at 90 degrees Celsius, so it's pretty close to boiling coffee, and a bathtub that's pretty close to boiling, which you should not get into a bathtub that's 90 degrees Celsius. That would not be wise. Okay, but for the purposes of this, let's imagine that they are 90 degrees each. Which one of these has more thermal energy? The coffee cup, which is, pretty small, or the bathtub, which is pretty large? The answer here is the bathtub. Since they're both the same energy, but this one has way more mass, it has more thermal energy, even though they're the same temperature. Which brings us to our final definition today, temperature, which hopefully you have a good sense of already, right? If we go outside and we say it's cold out, that's because the temperature is low, right? So we need to get a little bit more technical on this one as well. So this is a measure of the warmth or coldness of an object or space. And remember, there's no such thing as cold energy, so let's not be tricked by that definition there. This is usually measured in Celsius in science. So if you have one of the thermometers that I sent out, those have both Fahrenheit and Celsius, and let's mostly use Celsius in this class, okay? And then to add a little bit more technical language to that, the temperature is actually the average kinetic energy of the molecules in the object. So we're kind of bringing all of this information from this video together for this temperature definition. So let's go back to this bathtub example. The question now is, what's the higher temperature? Not what's the greater thermal energy, but what's the higher temperature? And hopefully you figured out that this is a trick question. Temperature is marked here on both of them, and it's the same. It's 90 degrees Celsius for each of them, because the average kinetic energy of the molecules in this coffee cup and of the molecules in this bathtub is the same. All right, so let's review that, because that was a lot of stuff to come at you all at once. And then you'll answer some questions about this in the standard Google form. All right, so which one of these has more mass? Again, this is the bigger cheetah. It has more mass than this little baby kitten cheetah. Now, let's assume that they're at the same temperature. Which one has more thermal energy? These are the same temperature. Which one has more thermal energy? The answer here would be the bigger object. Since they're at the same temperature, this cheetah would have more thermal energy. All right, which one of these has more kinetic energy? Again, it's the little zippy puppy because it's moving a lot faster and they're about the same size. All right, which one of these has more thermal energy? They are at the same temperature, so the larger object has more thermal energy because it has more molecules moving at that same speed. And which one has a higher temperature? That's a trick question. They are the same temperature. All right, and then last one here, this kind of brings together some of our ideas. These are some close-ups of water molecules. This is frozen, so this is ice. And this is a gas version of water, or water vapor. Which one of these has a greater thermal energy? And you can tell that they're roughly the same number of molecules. So let's assume they're the same mass, okay? Which one has greater thermal energy? Let's think through this. So ice we know is colder. We know that colder things have slower moving molecules. Water vapor is really hot. It's like boiled water, right? And so we know that hot things have really fast moving molecules. And we know that fast moving molecules means higher thermal energy. So this one would have higher thermal energy and it would have a higher temperature as well. All right, that's it. Go ahead and do those questions on the Google form. And some of this stuff can be really confusing. So please ask me questions if you are confused. Send me an email or chat me and we'll talk about it in class also.